Hello and welcome to Real-Time Signals. Today we are going to discuss one more project which is about predicting a person is going to suffer from heart stroke or not. Here you know it's going to be 1 or 0, so we have to apply classifiers. In this project we have applied many classifiers and PCA to see the performance with various classifiers. Let's go through this project. So as you can see, I've got two sets of data. This internet data is available over the internet. Here you can see that there are two sets of data. One is test data, another one is train data. In test data, we are going to predict. In train data, we already have the label, which is going to be used for training your algorithms. So you can see the features here: his person's age, gender, whether he had any hypertension before, he had heart disease, his he is married or not, his work type, his resident type. All these information is available. So with these features, we are going to predict by using our machine learning algorithms. So first we will train our algorithm and then we will predict. So let's do some more. So here you can see the test data, it doesn't have the label, whereas the train data will have the label. With you by using dot head, you can just watch few of the initial data set. So that's what I'm doing here. Okay, so total train data we have got 40,000, 43,400, and test data we have got 18,601. Now the first thing we have to do is data pre-processing, data filtering. So we need to find out if there are null or there are not a number type of data in our dataset, because if we provide not a number or null to our machine learning algorithm, it will not be able to predict. So first we have to filter out the data. So here you can see there is this column of BMI and smoking status. There are a lot of null data. Okay. So now similarly for the test and train, both has got this BMI and smoking status not available or not a number. So we are going to do pre-processing. We'll use a module called drop and a to drop the data which are not a number. Okay, so after doing that, you can see we are left with 29,072 train data and 12,423 data. So with that, we can then start looking at various features individually by using module called unique. So now let's take one by one. For example, we can check the smoking status and see how many of this how many of them are smoker, non-smoker, are getting heart heart stroke or not. Similarly for gender, we can find out. For example, here you can see there are female 17,539 out of them, and then 313 have got heart stroke, and males are 10,972, 235 have got heart stroke, and others who are 7. And then you can check the histogram of this. This is how it looks like. Now let's take another feature, and which is called smoking status. So in the smoking status you can check there are 3 smoking status we have. One is formerly smoker, never smoked, and the people who are smokers. So 6,919 are formerly smokers. Out of them 180 have got heart stroke problem, and similarly for the smokers. So this way we can check each individual feature and come up with an idea for the classifier to design your algorithm. Now we have to do, next thing is we have to do the label encoder. Basically we have to provide all integer to our machine learning algorithm, but in this data set we've got mix of string and integer. So we have to convert all the integer to all the string to integer so that we can use this data for machine learning algorithm. So this is what is done now, and it is a clean data which are just integer. So first I'm going to use NaiveBayes model for this classifier. So now let me run this, and I already ran it. This is a already available code in my Jupyter notebook, which you're seeing now. So now let's take a look at building naive-based model, and I applied Gaussian naive-based algorithm on it. The score is 92.33% of this algorithm. Then I am using cross validation. So cross validation is going to use same naive-based algorithm, but here I've applied cross validation of 5, which means it is going to divide the test data, uh, basically the output data, and he is going to divide them into 5 portions, and in these 5 portions he is going to apply one by one with various with this same model, and do a training one more time by using NaiveBayes. So this is a cross validation algorithm, and here you can then check the percentage is 92.58% for this test score. So last time we were getting 92.3, but here you can check that it is always more than 92.3 for various iterations. So this is better than before NaiveBayes. Now I hope you know NaiveBayes confusion matrix. Confusion matrix is basically true 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 false false true type of a thing, and you can check the performance of your algorithm, machine learning algorithm. Then I applied a decision tree model on this data. So here in decision tree model we can see that the output is the score is 97.88%, which is way better than NaiveBayes and cross validation. Then I applied neural network on it. So with the neural network it is this is the output, the classifier output, and the score is 98.15%. Then this is the dimensionality reduction by using PCA, principal component analysis. With this PCA we are going to reduce the feature, which means the dimension of our data is going to be reduced. So this is PCA helps it faster and also improves the score. So you can see the see that our DT score is 97.8%, and NB score, which was 92% before. Uh, so so here I applied PCA on the data, and then I applied all the algorithms which was done before, which includes decision tree, NaiveBayes, and neural network. So here you can see the score after applying PCA. It is somewhat better in NaiveBayes. NaiveBayes was 92.55% by using cross validation. Now it is improved to 97.94%, and the decision tree and neural network is somewhat same. Not much of a difference, but definitely you should utilize PCA all the time. That's it. Thanks for watching. Bye.